SV Math Teach back this time with completing the square. Now, you've probably learned many different ways to solve quadratic equations. Completing the square is just yet another strategy that you can use. It's also really good for graphing, honestly, because you can turn an equation that's quadratic into vertex form, and then from vertex form it's pretty easy to graph quadratics. There's two things we're going to look at. We're going to look at how to actually solve without graphing, and of course without the quadratic formula, and even without factoring. And then the second thing we're going to do in purple is show you how to rewrite this thing in vertex form if the goal is graphing. All right, so let's start with the first one. There's 5 steps to this. You can screenshot this and take it in if you need to. Anytime you're going to deal with completing the square, you're going to rewrite the problem where your constant is on one side and your x values or your variable terms are on the other. You're going to take the b value and you're going to cut it in half and then square it, and then you're going to add that to both sides. We're going to lean heavily on that old school rule that you can do anything you want to one side as long as you do it to the other. We're going to then move down to factoring, so we are going to do a little bit of factoring here. Once you factor, we're going to have a perfect square trinomial, so we're going to be able to do a square root of that square, and then we're going to solve for x. You're probably going to get something that is going to be either heavy in radicals or, if you convert it with the calculator, into decimals. I'll show you how to do that. One final thing that you should note is that you notice that in my little version here with the blue arrow, rewrite into x squared plus bx equals c form, you notice there's no a value. Now, if I put an a in there, I'd have to put a little extra note that a has to be 1. To complete the square, you really need your a value to be 1. And if you don't have that, then it's not going to work. So let me show you how that works. First and foremost, here's an example of something that is ripe for completing the square. The a value is 1, whether I have it written in blue or not. I see that this isn't going to factor. The only factors of 13 are 1 and 13, and there's no way to get an 8 out of 1 and 13, so factoring is not a strategy. I said that in the beginning we don't want to use the quadratic formula, though that would be also a great way to solve this problem. And just because I'm going to be stubborn and because I don't like the accuracy of them, I don't want to do the graph, although a tool like Desmos would help a lot. So here we go. Step number, I guess I should have these steps down here, right? So let's go ahead and grab these and let's copy and paste it right next to the question so we can kind of refer to them as we go. Let's make them teeny tiny. And here we go. So step number 1, let's rewrite this first problem that we're on. Let's rewrite it into x squared plus bx equals c. That really just means move the 13 over. So I'm going to get x squared plus 8x is negative 13, right? Subtract 13 from both sides. Now step number 2 is take the b value, cut it in half, and then square it. So my b value is 8. If I cut 8 in half, 8 divided by 2 is 4. 4 squared is, because that's what we're supposed to be doing here, is 16. So I'm supposed to be adding 16 to both sides. So let's clean this up. And I'm going to go x squared plus 8x plus 16 is negative 13 plus 16. All right, you'll note that though it looks like I changed the equation, I really didn't, because I just added the same thing to both sides, and that I'm completely allowed to do. By doing that b divided by 2 squared thing, what I've created now is a perfect square trinomial. So on the left-hand side, I have a perfect square trinomial. So I can go ahead and set this up using factoring. And on the right-hand side, negative 13 plus 16 is 3. All right, so now I've just done the factoring piece. All right, now I'm going to go down to the square root piece. Right? The square root piece is, let's get rid of the square. So you can do anything you want to one side as long as you do it to the other. I end up getting x plus 4 equals, now positive or negative, the square root of 3. You do need to remember the positive and negative version, so that's important. And now at this point, we're going to go ahead and solve for x. We're going to do that by simply doing minus 4. Now, if you need a precise answer, your answer is positive or negative square root of 3 minus 4. If you want to estimate this, and a lot of you are going to do that, you're going to say that it's plus or minus approximately 1.73. I did that with the calculator, minus 4, and then you could go ahead and nail down both of those answers if you need to. So positive 1.73 minus 4 is, what is that? That's negative 2.27 it looks like. And if you do the negative version, negative 1.73 minus 4, you're going to get approximately negative 5.73. So these are your two estimated answers. These are your two perfect answers, the positive and the negative version, and that's the solution. All right, that's it. If we go down to a second question, sorry, I have one over here. I'm not going to work this one out because I want to keep the video kind of short. But you'll notice that this one is also a problem that, while it doesn't appear so, could be done using completing the squares. But you might also notice that that thing is not supposed to be there. Right? We need an a value of 1, not an a value of something that's not. So we can do something pretty easy. We can just go ahead and factor out a 2, and it would look like this. X squared minus 12x plus 7 equals 0. And then at this point, what you would do is you would just work down and do the inside piece. I'm not going to do the whole problem, but I am going to do just enough to give you a caution on this in case you find yourself needing to solve one of these on maybe a quiz or a test or a challenge problem, because this isn't really a very good candidate for completing the square. I'm going to go ahead and do the same thing as before. I'm going to try to rewrite the problem. And here's the issue, though. So I'm going to do x squared minus 12x. I'm going to leave a blank. And then imagine this. Remember how this 2 and 7 is really 14? And I would subtract 14 from both sides. I'm going to do a minus 14 over here, and I'm going to leave this space kind of empty. Right? That's going to be key. So all I've done is taken the 14 and move it over. Right? That's the negative 14. And I'm going to leave room for my next piece. So b squared, that would be 12 over, b divided by 2 squared. So 6 squared is 36, so I'm going to add 36. But over here, watch this. This isn't 36, this is really 72, because it's 2 times 36. So this is where completing the square starts getting pretty messy if you have the wrong kind of question. As long as you can keep all that straight, though, there you go. You got your 2, you got your x minus 6 squared. Over here, 72, 62, what is that going to be? 58. You could divide both sides by 2. You could take the square root and so on. Right? So it can be done. It's not ideal, but you can do it when the a value isn't 1, but you have to force it to become 1. And then you got to really watch and be careful with all your other numbers. So the ideal form is when you have a beginning question when the a value is already naturally equal to 1. Now, I had said that we would look at vertex form as well. Vertex form has a lot of similarities. The only difference is if our goal is to rewrite in vertex form, I'm going to stay in blue here. If our goal is to rewrite in vertex form, we don't necessarily have to solve it. We're just trying to rewrite the problem. So I'm still going to use some of the same strategies, but you're going to see a little bit of a different change here. First and foremost, I still think you're going to need to get this value to be equal to 1. The a value has to be 1. So we're going to use that same strategy as before. I'm going to go ahead and factor out that a value. So factor out the a value of 2, and we get x squared minus 4x. I'm going to do the same thing as before. I'm going to leave a gap there, and I'm going to take this plus 1 and write it down here. Okay, I'm going to leave a space because I know I'm going to need to add that space in there. Let's clean this up a little bit. Maybe I'll leave this in for anyone watching the video. Next step, let's go ahead and deal with step number 1, add or subtract. Now this isn't add or subtract. I made a mistake there. It's add and subtract the half of b squared. Now half of b squared is going to be negative 2 squared, which is 4. Now watch this. I'm going to add 4, but then over here, because I'm doing this to the right-hand side, right? Notice I just added 8. I know I said added 4, but because of the 2, it's really a plus 8. I need to then do a minus 8. So this move here, because of the 2, is a plus 8. And this move is a minus 8. And the plus 8 and the minus 8 on the same side, they undo each other. So while I'm making my problem look different, I'm not actually harming the problem in any way. All right? All I'm doing is doing steps that are completely legal. Now here we go. Next step, factor the perfect square trinomial. So y is 2, and this is going to be x minus 2 squared. And while I'm here, I'm going to go ahead and clean this up. That's kind of like the simplify piece. Minus 7, and we're done. There's vertex form. Right? My vertex is 2, negative 7. My a value is 2, and I could go ahead and graph the quadratic from there. So pretty simple. Using these couple different techniques, you can go ahead and work with completing the square. The most important thing, though, is that when completing the square, you need to force that first value into being a 1. You need to get rid of anything that's in front of it. And if you see something in front, you absolutely must get rid of it, and you can do that with factoring. So good luck using completing the square to both rewrite problems in vertex form and to solve problems that are quadratic.